for how did you start this one? Any ideas? And do you have any ideas? Yeah, take the derivative, because if you look at any function, the maxes and mins will have a slope of what? Slope will be 0. So we're going to take the derivative of this guy, get 3x squared minus 6x minus 9, and set it equal to 0. Just by looking at that quadratic, how many zeros are we going to have? What's that? 2, yeah. So if we set it equal to 0, that's what we use to find max and mins. We want to get the 2 max and mins. So this is going to be, I'm going to take out a 3. 0 is equal to 3 times x squared minus 2x minus 3. And that'll factor into x minus 3 and x plus 1. Does that give us negative 2 for the middle? All right, so we're going to have 2 values, x equal to negative 1 and x equal to 3. Now we've got to go back and look at what the question is. Find the equation of the straight line passing through the max and the min. So we probably need the y values for these 2 points. So I'm going to take this negative 1, put a negative 1 in. F of negative 1 is going to be negative 1 minus 3 is negative 4 plus 9 is 5. I think it's 15. Anybody get that? Anybody second that? 15? Okay. The other one is going to be 3, a little bit more difficult. 27 minus 27, well, that's nice. And then it's going to be negative 27 plus 10 is negative 17. Anybody second that one? 17. Good. All right. What good are those 2 points? Yeah, all we need are those 2. We can find the slope is the change in y. 15 minus negative 17 is 32. And negative 1 minus 3 is negative 4. I get a slope of negative 8. Anybody second that? Is that okay? So then the actual equation of the line will be x minus negative 1 times negative 8 is equal to y minus 15. Now that isn't the way they wanted it. They had negative 8 times x plus 1 equals y minus 15, which is going to be plus 15, is equal to y. If you want to simplify, it's negative 8x. Negative 8 and 15 is 7. That's the equation of the line that'll go through those 2 points. And you know that's true because if you put in a 3 here, you're going to get negative 24 plus 7 is negative 17. Put it in negative 1, you're going to get 8 and 7 is 15. So you know those are good. Show that the point of inflection lies on that line. Well, that's pretty cool. The second derivative equal to 0 is going to be 6x minus 6. And that's going to be x equal to what? X will be equal to 1 for that one. And when I put that into the original equation, y is going to be equal to 1 minus 3 is negative 2, minus 9 is negative 11, plus 10 is negative 1. We have to show that 1, negative 1 works here. What's negative 8? Let's see. Y is equal to negative 8 times 1 plus 7, which is negative 8 plus 7. What's negative 8 plus 7? What? Therefore, true. Exists on the line. 7's a good one. A continuous random variable x has a probability density function given by find the value of k, find the mean and the median. We may have done some like this. Maybe we've done one, this very one, I don't know. But it says, what do you know about the area of k times x plus 2 squared from negative 2 to 0 plus the area k goes from 1 going from 0 to 4/3. What should this area be equal to? 1. Yeah. So it's a probability density function. These areas should add up to 1. And then for the mean, this is the tricky one. Once you know k, you're just going to take each of these to find the expected value or the mean, and you're going to multiply by x. It's horrible, but that's what you're going to do. And you still have to know what k is. Remember doing that? Does that sound familiar? Anybody unfamiliar with that? And then for the median, I'm going to let you see if you can figure that one out. For this integral x plus 2, if u is x plus 2 and du is just dx, this is just going to be x plus 2 cubed over 3, isn't it? Okay, and this is going from negative 2 to 0, and this is times k. This one is just going to be the antiderivative of 1 is just x going from 0 to 4/3 times k, right? That's going to be equal to 1. So I'm just going to move over to here. And so it's going to be k times, let's see, I'm going to put a negative 2 in first, which will make this 0 minus, now I'm going to put in a negative, oh wait, negative 2 is not first. 0 is first. 0 is first, and that means I'm going to put a 2. 0 plus 2 is 2 squared over 3 minus 0 squared, or cubed, over 3. And then it's going to be plus k times 4/3 minus 0. That should be equal to 1. So getting a little of the algebra going here, this is going to be 8/3 k plus 4/3 k equal to 1. That's 12/3 k equal to 1, and I think k is going to be 1/4. Did anybody agree with that? Is that all right? Okay. So now this green k can disappear, and now we replace it with 1/4. 1/4 seems reasonable because we want the area to be 1. If it were any bigger, it probably would be too big. So now, when we do this one, a little bit more work because we have 1/4, the integral from negative 2 to 0 of x squared times x is x cubed. 4x times x is 4x squared. 4 times x is 4x. All right, right? Because you got to expand this and then multiply by x. This one is a way easier. This one is just going to be x squared over 2 going from 0 to 4/3. I integrated this one. And that's going to be equal to my answer. So this is going to be x to the 4th over 4 plus 4x cubed over 4 plus, actually 4 times 3. And this is going to be 4 times 4. 4x squared over 4 times 2. Going from negative 2 to 0 plus, let's see, if I put in a 4/3 squared over 4 times 2 is 8 minus 0. Now we got to put in these numbers. Well, I love the 0 first. That's great. That's just going to be 0. Minus, now we're going to put in a negative 2, which is just 16 over 16. Negative 2 is going to be a negative, these will cancel, 8 over 3. And then this is going to be a positive 4 over 2 plus 16 over 9 times 8. Ooh, so this is going to be 1, 2, 3 minus 8/3, opposite of that, plus 16 2/9. And this is going to be 9/3 minus 8/3 is negative 1/3 plus 2/9, which is going to be negative 3/9 plus 2/9 is negative 1/9. Anybody else get that? Okay. And can the expected value be negative? Yeah, because the expected value can be in the win column, positive, or in the lose column, negative. What do most of the gaming outfits want the expected value to be? Negative. They want it in their favor, not in yours. And as I mentioned before, your lotteries are about negative 26 to 35 cents loss on every dollar for you. So don't play. It's still what? We hope. We hope. We hope. All right, then for median, all I'm going to say about the median, I'm not going to do this one for you, but I am going to get you to think about this a little bit. The median is the value where the integral adds up to what? What's the integral going to be? Not 1, but 0.5. So here's the tricky part of this. You have two functions, and you don't know where it's going to end up. So here's what I would do. For the median, what was the area from 0 to 4/3 of k was 1/4, right? 1/4 dx. What is that area? Well, let's see. It is 1/4 x going from 0 to 4/3, which is 4/3 times 1/4, which is what? 1/3. Are you okay with that? Okay. I'm going to make a little scale here. 1/3 is right here. We want the median, 1/2. Where is that going to occur? Is it going to occur in A region or B region? A region for sure. So don't even mess with this unless you want the, well, I'm not even going to say it. The easiest thing to do here is to go from 0.5 to 1, or no, not 0.5, m to 1 of x plus 2 squared over 4. And that should be equal to 0.5. No, you're right. You're right. No, you're right. To -2. Yeah, -2 to m. That's right. -2 to m, and that should be the half. Yep. Because this will be only 1/3. So if we start at the bottom, -2 up to m, it's it's going to be somewhere in there, which will give you the 1/2. Is that okay? That's the only tricky part of that. And I drew this wrong, so let me try it one more time. This is -2, and this is 0, and this is 4/3. This part up here is only, as we figured it out, 1/3. So if we're looking for 0.5 or 1/2, you're going to have to go from -2 up to there. Isn't that interesting? That's kind of cool.